So we're looking at finding the inverses. Of course, step one of finding an inverse, no matter what it is, whenever you see inverse, that should make you think to swap x and y. And so my first step on this first equation is turned into x equals 2y. All right, now that I've done that, we do want to actually solve it for y. So let's go ahead and solve that for y. That just means dividing both sides by 2. So therefore, x over 2 would equal y. And that's all we got to do there. And it's just a matter of details from there. So, in the case of the second one, well, swap x and y first. Remember that f of x is just a fancy name for y. So I'm going to go ahead and turn this into x equals y squared. And now I can solve it by taking the square root of both sides. When I take the square root of both sides, what do I need to remember to include? Yep, that plus or minus in front of the square root. Now, one last little detail in this particular question, though. Because the original one was f of x equals, I want to use that same f of x notation for this too. So I'm going to say the inverse of f of x equals plus or minus root x. And remember to write that inverse when we do function notation. It looks like the power of negative 1. It isn't actually, but it's written the same way as the power of negative 1. All right, and then for the last one, again, start by swapping x and y, so we end up with x equals the square root of y. And then we're solving for y, so I got to get rid of the square root, so I'm going to go ahead and square both sides. So that will give me x squared equals y, which is half true. Because remember, if I graphed a square root here, it would look like that. It does not look like that. It does not have both a top and a bottom. It only has that one side. And so in my inverse as well, I only need to have one side of it, not both. And so this is where we add in one other little detail. We say that yes, that is the equation where x, and here we know what to write next because we know the original range. The range of this original is y is greater than or equal to 0. Therefore, where x is greater than or equal to 0, because the original range becomes the inverse's domain. And we restrict the domain in order to have only half the parabola showing up. All right, two last ones. Please find the inverse of both of these. And so, of course, we start by swapping x and y. And so for this first one, the g of x is just the fancy name for y in this case. So it's going to be x equals y to the fifth. And now I want to undo the fifth power. Well, when I wanted to undo a square, I did a square root. So if I want to undo the fifth power, I'm going to do the fifth root. So I do the fifth root of x equals y. And again, I do want to put this back into that function notation since it started out as g of x. So I'm going to call this inverse of g of x equals the fifth root of x. Now, in this case, do I need to put in a plus or minus in front of my radical? No. The reason is because it is an odd root. I only have to do that for even roots, like a square root or maybe a fourth root. But for a fifth root, remember something to a negative to the power of 5 equals a negative, so we don't have to worry about the plus or minus thing here. All right, last one here. We got y equals 5 to the power of x. Step 1, swap x and y, of course. So that gives me x equals 5 to the power of y. And now I need to solve this for y. And this is where an old friend from way earlier in the year that keeps coming back and visiting us comes back once again, but this time he's going to be staying. Because I need to be able to solve for the exponent. What can I use to solve for an exponent? Remember, this is why logarithms exist. It's to solve for exponents. So, this is mostly already in your notes. Now, if you kind of lost it or something like that, by all means write it down again. But this is bringing us back to what we know about logarithms. The piece that is kind of new here that's going to be our big point of emphasis at least, is this last line, which probably is not written in your notes with the logarithm, so you might find it and add it. Logarithms are used to solve for exponents. It's the whole purpose why they exist. And so going back now to this problem where we're finding our inverse, remember we need to solve this for y? We're solving for the exponent. Remember, that is why we have logarithms. So in order to be able to solve this for y, I'm going to rewrite it as a logarithm. So we're going to go log base what? What is the base of my logarithm going to be here?
5.
Yep, it is base 5. And that's log base 5 of what? X. Yep. Because log always equals the exponent. So even if you forgot where the x went, you could put the y in, and then you would know by process of elimination. And notice, this is the inverse now, because I got y equals. So now we can also see something else about this. The inverse of an exponential is a logarithm. All right. Now, I think we're pretty good with our logarithms. I was going to have us practice rewriting our exponentials as logarithms and vice versa, but I think you got this down. So I'm going to skip past this. And then I want to do at least one of these. Do you remember how to evaluate a logarithm without a calculator? So, log base 7 of 49. If you don't remember how to do that one, how would you write it as an exponential? Yeah, to write this as an exponential, it would be 7 to the power of x equals 49. If I write it that way, what does x equal?
2.
Yeah, x equals 2, because 7 squared is 49. So when you see a logarithm, what you want to do is you want to read it as the base to the power of what equals that number. So like 3 to the power of what would equal 81? Well, 3 times 3 is 9, times 3 is 27, times 3 is 81, so that was a grand total of 4. And 5 to the power of what is 125? That is one of those values that I want you to know. 5 cubed is 125. And again, I'm going to kind of scoot through these pretty quickly, but I do want to remind you about how to do these. So like for that first one, if I want to calculate log of 150, all I have to do is type in 150 on my calculator and press the log button. It gives you like 2.18, no problem. But if I want to figure out what log base 2 of 40 is, I cannot do that. Most calculators do not have a log base 2 button. And so instead, this is where we had the change of base formula. This should be with your logarithms notes. If you don't remember having this in your notes, take a moment, write it down now, because this is how we're going to be able to calculate those values. All right, and so now let's see how we would use this. If I want to be able to figure out what log base 2 of 40 is, that means I would type in log 40, and I would divide that by log of 2. And so you can check yourself. That would give you 5.32. And so the last thing I want to remind us of, when we took a look up here at just log of 150, what was the base of this logarithm even though we did not write it in? If you did not remember that, you might want to add this into your notes as well to remember that log means log base 10.